Problem 26, remove duplicates from sorted array. In this problem, we have an array called nums. It's sorted in a non-decreasing order. So there could be duplicates. And we have to get rid of those duplicates in place. This has to happen in place. So this 1 is okay, we can keep it. The first occurrence of 5 is okay, we can keep it. The second occurrence will be thrown away. First occurrence of 7 is fine. First occurrence of 8 is also fine. Both occurrences of 8 will be removed. The first occurrence of 9 will be kept, and the second will be removed. Now here we will have some potential garbage. That does not matter because we're going to be returning the number of meaningful elements, after which the truncation is going to be assumed. So these elements do not matter. That's the idea. So in order for us to do this, we will do the following simple algorithm. So I'm going to have 2 pointers. The first pointer I'm going to call length. This will be the final length of the array that we're going to return. Now, potentially, we could be working with an empty array even. So potentially length could be returned as 0. We should be able to, so we should not start with length 1, for example, even though the first element will always be unique occurrence of itself, the first occurrence of itself. So if there are any elements in here, then potentially we could start the length with 1, but because we might, I don't know whether the problem allows this or not, if we could potentially be dealing with empty arrays. All right, so we're not dealing with empty arrays. Okay, in that case, we could potentially start by saying length equals 1. So length means, that means we have one element, which is definitely okay. And then we could start going through all of the rest of the elements with a second pointer, I. So I will be initially looking at the second element. At each iteration, we'll be comparing element with the index I with the element of the index length minus 1. And if they are different, so length minus 1 and I, right? So these two elements will be compared. And if they are different, then we would be copying, basically, the copy will happen to the element of length. And we'll copy element I, but length would then need to be incremented post-increment, right? That would work. That would do it. Let's try to write this now. So potentially we could say if nums length, so if that doesn't exist, so if it's an empty array, then we could just return what? We could just return 0. That is not necessary because, we are assured that length is at least 1, but this would make it work even for empty arrays. Now, after that, what we will do is we will set a variable length to 1, as we said. We can do this now because we know that length definitely is more than 0. Or let I equals 1. I is less than nums length plus I. So now we are going to compare this element. This is I equals 1. We're going to compare it to length minus 1 to element at length minus 1. So if nums at length minus 1 is not the same as nums I, then we should copy this to length post increment equals nums I. And in the end, we're going to return length. Yeah, I think that should do it. Let's try this on our test cases. We have a couple of very simple test cases here. Okay, both were passed, accepted. Now we can submit it to the full suite of tests and see what happens. Okay, so we are fine. Runtime is pretty decent. Memory usage is, we beat 74%. With TypeScript against C++ and some of the other more efficient languages, with this interpreted language against some of the compiled languages, this is a pretty decent going. So anyway, let me just submit it one more time to see how consistent this value is. So 58. Okay. Anyway, this is probably the overhead. The memory is overhead of the TypeScript language itself. I don't think you can remove too much memory usage from here. We just have two variables, length and I. There is nothing else we're using here. So two integers shouldn't be, it's difficult to think how this can be done without using two integers at least. So this result here must be the overhead of the language itself, the disadvantage that we have to solutions written in, say, C++.